So I will start all over again. I was talking about redox reaction. So let me remove these parts and then I will start all over again. So again, I said redox reaction. So the redox is from two words red and then the second word ox. So the word red, so let's start from the word red, which stands for reduction. The one stands for reduction, and then the ox stands for oxidation. So it means we need to know the definition of oxidation and reduction. So we will transfer that to the word redox. So when we say oxidation, the general term or the general definition of oxidation is gain of oxygen. It is easy. Gain of oxygen. That is easy from the word ox here. So the ox is from the word oxygen. So gain of oxygen, I will go down to that as we go. And then reduction is just the opposite of gain of oxygen, which means loss of oxygen. So when we say gain of what gains oxygen? So I will say gain of oxygen by a substance. Gain of oxygen by a substance. By a substance. And same thing, loss of oxygen by a substance. So what is that substance? So we use chemical equation to explain that oxidation. So let's focus on oxidation first. So gain of oxygen by a substance. So we know that oxygen is the chemical formula for oxygen, or the chemical symbol for oxygen is O2. And then when we say gain of oxygen by a substance, so what is that substance? What can that substance be? So let me remove this first and then let's have the substance. So I will use magnesium as our substance. So whenever magnesium reacts with oxygen, it means magnesium gains oxygen. And eventually, you are going to have a new substance that shows that magnesium actually gains oxygen. And that what you're going to form is magnesium oxide. So at the reactant side here, you have only magnesium. So when it gains oxygen, it becomes magnesium oxide. So this is process of oxidation, the gain of oxygen by magnesium. So you can do this. Just put an arrow from from magnesium to magnesium oxide. So when magnesium gains oxygen, it becomes magnesium oxide. So this is oxidation. This equation it was not balanced, so let's balance it. It's very important you balance an equation. So we have two atoms of oxygen, so we're going to put 2 here, and then the 2 has affected magnesium, so we have 2 Mg here as well. So that is magnesium, that is oxidation, gain of oxygen by magnesium. So what about reduction? So let's write something about reduction as well. So we said reduction is loss of oxygen. So we can use copper 2 oxide as an example. So whenever copper 2 oxide reacts with hydrogen, let's see what we are going to form. Remember we said loss of oxygen is reduction. So it means we are expecting copper 2 oxide to lose oxygen. So it means at the product side here, we are going to have copper alone because copper has lost oxygen. So what collect that oxygen from copper is hydrogen. So we are going to have water here as the second product. So if you look at this very well, you will see that it is actually reduction, this side of the equation. The reduction means loss of oxygen. We have copper together with oxygen at the reactant side, but at the product side, we have only copper without oxygen. So this is reduction, which is what? Loss of oxygen. Now, I think you need to be wondering, why do we put arrow from magnesium to magnesium oxide alone, and we don't put from oxygen to magnesium oxide? At the same time too, from hydrogen to water. Because if you look at this side of the equation, from the side of hydrogen, you will agree with me that hydrogen actually gains oxygen. The oxygen lost by copper here is gained by hydrogen to become water. So it means reduction happens on copper 2 oxide to become copper. At the same time, oxidation happens on hydrogen to become water. So this is oxidation. So this one is telling you that both oxidation and reduction occur at the same time. So I will write both oxidation and reduction occur at the same time. Sometimes they will say they occur simultaneously. So it means whenever oxidation is occurring, reduction is occurring at the same time. At the same time. So there is no oxidation only when one side of an equation is oxidation, the other side of an equation of that equation is reduction. So it means regardless of what is happening here, since we know that we have established that magnesium to magnesium oxide is oxidation, oxygen to magnesium oxide is reduction. So reduction. All what you need to know is to understand one side of the equation, one half of the equation. The other half will complement the side that you understand. But this one is really obvious, this side. Copper 2 oxide loses oxygen to become copper. Hydrogen at the same time gains oxygen to become water. So this is the definition of oxidation and reduction in terms of gaining and losing of oxygen. So before we end this demo class, let me give you this next definition of redox reaction. This is redox. I would say this is redox. Redox in terms of loss and gain of electrons. And that is the most comprehensive definition actually, because there are some reaction. For example, I will give you this reaction between sodium and chlorine to give you sodium chloride, NaCl. So we have to balance the equation. We put 2 here, and then we put 2 here. This equation is balanced this way. Now, if I tell you that this reaction is a redox reaction, will you believe me? You may not believe me because according to the definition that we have up there, we said oxidation is loss of electron. We said oxidation is gain of oxygen, and reduction is loss of oxygen. So if this reaction is a redox reaction, where is oxygen? There's nowhere we can find oxygen here. That is why we're talking about the new definition, which is redox in terms of loss and gains of electrons. So this one, you need to understand the basic. You have to have a basic knowledge of what do you call it? electronic configuration. So the first definition, or before we establish the definition, so let's look at what happened to sodium to become sodium chloride, and what happens to chlorine to become sodium chloride at the same time too. So remember that sodium atom is element number 11 in the periodic table. So if it is element number 11, so the electronic configuration of sodium is going to be 281. And for chlorine, the electronic configuration of before let's go for with sodium first. So sodium is 281. Remember, I don't know if you should know that in the past that metal, they like to lose electron whenever they want to react with another substance. Whenever metal or a metal want to react with another substance, metal will lose electron in that regard. Now, why do they lose electron? Because they have less electron at the last shell. For example, if you look at sodium here, sodium has 3 shells. The first shell has 2 electrons, which is the inner shell. I can draw it. So this is the first shell. This represents the second shell, and this represents the third shell. So I don't know if I can rearrange it to make them better. Let's say if we can capture this. Yeah. And then, yeah, I only need to expand this up and then move it here. Yeah. So the first shell of electron for sodium, so I'll put Na here at the center, so we know we are talking about sodium. So this is Na. The first shell has 2 electrons, so it means 1 and 2. The second shell, which is the shell number 2 here, has 8 electrons. 1, 2, 3, 4, 5, 6, 7, and 8. And the last shell is occupied by only 1 electron. So this is the electronic configuration for sodium. So let's move this to one side. Let's put it here. So I will copy this and paste it. So let's paste it here. And then I will just modify this. Let me modify this. So I will delete this Na inside. This is so big. I'll delete the Na inside and I will change this to Mg, which is magnesium. So just to give you another example. So magnesium. Magnesium is element number 12 in the periodic table. If it is element number 12, it means the electronic configuration of magnesium is going to be 2, 8, and 2. The last shell will be occupied by 2 electrons. So it means instead of 1 electron here, there will be 1 more outside here for magnesium. Now, let's take one more. Let's take one more. So I think if I paste, I should be able to get it. Yeah. So one more. So in this case, I will change this to aluminium. And then aluminium is element number 13 in the periodic table. If it is element number 13, so the electronic configuration for aluminium is going to be 2, 8, 3. So it means the last shell will be occupied by 3 electrons. So let's do that for magnesium, for aluminium. So it is going to be 1. I think I'm using blue. So we have 1 here already. So we have another 1, 2, and then 3. So there are 3 electrons in the last shell of magnesium. So I will stop here because I noticed that you are not longer with me. I believe what we have done for the past 15 minutes should be able to convince you to register with me as a tutor. So, but if you want to do that, you should get your system ready. Your internet connection has to be stable, so you'll be able to hear me, and also reply to my whenever I ask a question or whatever I want you to contribute. You should be able to talk so I can hear you clearly, and it will be better. It will be very much better if you can get a laptop, which is going to be the best for you to enjoy the class. Thank you so much. You can also share the video with any of your colleagues who will be interested in the class with you. So when you are three, it means you are going to pay less than what only one person will pay. Thank you so much, and bye bye.